Welcome everyone to another session of working with ArcGIS. In this session, we are going to pick up from where we left. So we were working with vector data. We introduced ourselves to polygon, type vector data, and we looked at districts, states, taluks for India, and we sort of focused down to Uttar Pradesh. We looked at the districts level data on your screen. You have a bit of a visual. Let me just zoom to layer for your for your convenience. I will also remove labels, things that we have done till now. And what we did previously was, we used this intersect tool in the toolbox, the geoprocessing toolbox under view in geoprocessing. We used this tool under analysis, overlay, and intersect to provide an intersection of a line data, that is the railroads data for India, downloaded from DEVA GIS, and the districts level data for UP. And consequently, we created this table which is called as UP Districts Railroads Intersect Table 2 using this tool. On your screen, if we go to catalog, you can see the location of these data, right? We talked about managing data using Arc catalog. And on Arc map, we have a visual of the data, and on the table, in the table, we have this intersection of the rail lines as they pass through each district. We calculated the length of these entities. We actively added a field called length, and we calculated geometry and calculated length of rail lines passing through each of them. And we figured that if we focused on Saharanpur, we said, okay, select by attributes, and I want to select by name 2, and I want Saharanpur, right? So we did all that in the previous, towards the end of previous, okay. And I have these 11 of 437 units selected. And if we sort of focus on where these selections are, well, they will happen to be on the, in the Saharanpur district. So this is going to be a Saharanpur district. If I open the attribute table, I say select by attributes and I say apply, all the rail lines that are passing through Saharanpur are then selected as individual entities, right? So the FID Uttar Pradesh, which is 62, which refers to name 2, the district name being Saharanpur, is intersected with the FID of the railroads, which provide us individual unique railroad types, and then from these we calculated the length. So if I were to sum the length of all the selected portions, the 11 selected rows, then I will have the length of railroad lines in the Saharanpur district in UP. That's pretty powerful, right? We understand now, right, if we do data analysis, if we can get these data in comma separated format, which is the .csv or .xl formats, then we can do a lot of things on our traditional software like Python, on Stata. If you work in, if you're an economist, or you have experience working with Stata or with SPSS or with R, you can take these data there and then start manipulating them, right? So if I could sum the length by district, unique districts, then I will get the exact length of railway lines in each of these districts. So my next query or my next quest is really to be able to then export these data into a .csv format, which I can then take to my statistical softwares and start manipulating there, merging them with different data files, which I may have different district level data for, let's say, nutrition, for some health outcomes, for some agricultural outcomes, from urban development outcomes. And I might just want to merge the railroad length by district. So I could construct the railroad length using the visual maps and then export them as CSV and then merge them separately in a statistical software, right? So clearly something of interest to us right now is convert these data. So what you could do under geoprocessing, you have this under favorites, you have this option of find tools, right? You may access this option from anywhere. And in find tools, I'm just going to say export table, right? So it's very convenient. The ARC is really convenient. So I have this conversion tool called export table. It's going to be under conversion tools, briefcase, that sign that we have. If we go back, if we go back, this conversion tools, this toolbox, if I open, I will have a conversion export table, okay, Excel to table, table to Excel. So I have many different functions that I can use, right? So I'm going to just use the find function because I guess it's very convenient. We can do it for different other things as well, as we will see as we go. So we don't need to exactly know the location of each tool. We could simply find them, from the geoprocessing tab. Okay. So it says, okay, what does this do? Let's go to the question mark. It says exports the rows of a table or table view to a table. Okay. So it says table inside, which is a object of ArcGIS or ArcMap, which is typically a .dbf file. And we want to convert it to a .csv or .xlx, extension. So we say, okay, what's my input table? Well, it's UP district railroads intersect table. And my output table, I'm going to now save it at a known location. So I'm going to say, okay, I want to go to folders. I want to go to my practice sessions, and I want to, save these data here. So let me do it here. So I'm going to say UP districts railroads intersect .csv. Okay, so I'm going to just provide this extension on my own. I'm going to say save. Okay, and I'll then say run. Okay, so it runs it. It says, okay, export table is completed. Fantastic. And it gives me a .csv on standalone tables. But I don't want the table to be inside ArcGIS. Rather, I want to be able to open it on an Excel as an Excel file. So I'll go to my Windows Explorer. I'll go to desktop. I'll go to my location of the data. And okay, it's going to be under, okay, there we go. So UP districts railroads inter comes out as a Excel file right away. So if I double click it, there we go. It's an Excel file now. I can save it in any location. I can save it in different formats. You could save it as a text file. You could save it as a .csv file. You could take it to software like SAS, to R, to Stata, whatnot, right? To Python or whatever you are comfortable working with. So the entire data set has now been transported into this particular format, right? So I have my FID Uttar Pradesh, which is the original ID for Saharanpur. It is 62. So wherever I see 62, it's all Saharanpur, right? And here we go. The name is Saharanpur here. And then I have my railroad ID right here, right? And then I have length. And we figured in the last class by cross-validating using the measure tool that these are in hundreds of kilometers. Okay, so I'm just making sure that I have the unit right. I'm going to still save as. I'm going to say, okay, I will say convert ARC converted UP district level railroads. Okay, so I have my lengths. Now I can take it and I can do, okay, so I want to just save this file differently. I can just import it in any system. I can take it across systems. So now I have a way to take a data set from a ARC table to an Excel table, something I'm very used to. But what about the other way around? Okay, so what if I were to begin with an Excel file and I were to then convert it into a visual map and then analyze the data from there. Okay, so let's go on to doing that as a next step. Okay, so I'll go back to my ARC, my project, SSSC ArcGIS project. I'm going to close this table. I'm done with it, so I'm going to remove it, and I'm going to save my project. Okay, I'm always going to save my project so that I can return to it whenever I like, right, as best practice. Then I will do zoom to layer so that things look, not so bizarre. And now I'm going to show you a points data set, right? So the vector data occur as polygons, as lines and points. So we have seen polygons, we have seen lines, we have seen how they can both interact with each other. Now we will look at points. For that, I want you to pay attention to this India Water Resource Information System database of the Government of India. Okay, so you can simply Google India WRIS and it will give you, the first thing it will give you is India WRIS portal. On this portal, you can navigate to groundwater data. Okay, so you can go to, let's say, figure out for a given season, any season, in any year starting from 1993 till as recent as 2022, let's say we say 1998, right? And we say, okay, so there are 4 seasons, January to March, April to June, July to September, and October to December. All these seasons are basically quarters in a year, but they also map your monsoon seasons and the crop calendar of India, right? So groundwater monitoring in India logically happens according to the monsoons and non-monsoon seasons. So of course, July to September is the monsoon season. April to June is pre-monsoon. October to December is post-monsoon, right? And January to March is something like a post-monsoon, winter season. Okay, so you can choose the season and you can download these data, right? You can submit a request, you can download the data as an Excel file. Okay, so I've done that for you, beforehand. So I'm going to, close this window and I'm going to show you a data set that you can, get from there. So this is a groundwater levels data. Okay, cancel. Okay, there's something wrong. Okay, there we go. So here is a groundwater level data. This data is for the state of UP. Okay, separately downloaded. ID is what is this ID? We will see in a minute. Well, this ID belongs to a well code. So India's groundwater management agencies have or own certain wells in different locations in the country, from where they go in and they monitor groundwater levels, right? So they measure the level beneath the ground surface, how far down the groundwater is, where is the water head. If the water head falls below, that means depletion, right? And that means alarm, right? And alarm if it depletes quite a bit, let's say within a season. If there is a dry season, if there is less rainfall, well, you're going to have some problems, right? These are the data that I was showing you through the lecture series as well, right? So you can now, using these data, go back and revisit all the different things that we talked about these data. All of those functionalities that we talked, we can do all of those on ArcGIS, right? We won't have the time to do that through this particular module, but once you are able to use these data, play with these data, analyze, manipulate these data on, on ArcGIS, you can, do all those functions on your own. Okay, so what do we have? We have these well codes. Against each well, I have a latitude and a longitude. So I have my XY coordinate exact location on a map where that well is located. Okay, and the data is in public domain. Then I have the year, which is 1998. So this is the data for 1998 and it's post-monsoon Kharif. Okay, Kharif is the season of cropping, which happens, Kharif is during monsoons. So it's going to be the July, August, September. And post-monsoon Kharif then would probably mean, either those 3 months or October, November, December. So it's one of those months which is after monsoon, probably just after the Kharif season. And what you see as values here are meters below ground level. So at this particular well in Bagpat district, at this location in 1998, the waterhead was 8.8 meters below the ground surface, right? So this is now powerful data. I'm used to working with these data, right? It's a cross-sectional data set for all its worth. If as applied statisticians or applied econometricians we know that this is a cross-sectional data set. Now, how do we think of this as a spatial data set? Well, there is a spatial delineation. I have the lat long. The question is, how do I now exploit this spatiality of the data? Okay, that's where ArcGIS will come into picture. Okay, so we are going to go back to our software. We are going to the soft folders. Okay, so I have my my folder that I had added previously, and in that folder I have this point vector data and I have my groundwater XLX. So I'm going to just drag it. I'm going to just double click it and hope that this will open in my table. It seems it won't. So I'm going to do one thing. I'm going to go into map. I'm going to click on add data. I'm going to go to my folders. Okay, so vector, then I have my XLX file. Okay, so this says groundwater level 1988. It's a typo. It should be 1998. And this has a $sign, so this should be sheet name. So let's go back to our Excel file and see for sure if we have that name. So we have groundwater level. So it doesn't say that. So let's see. Okay, one second. I have a little snag here. So groundwater level. Okay, and groundwater level. Okay. So I'll go back and I'll just try and import this sheet. Here we go. Let me open this data set, groundwater level 1988. It should be 1998. So, by the way, I can simply correct the typo. Okay, I'm done. Now I can open it so that everything remains correct. Okay, perfect. So I have my ID, I have my state, I have my district, my well code and my lat long and year 1998 post monsoon kharif 8.8. Okay, so here is my Excel sheet and I've added this data using this tool called add data. Okay, I wasn't able to drag this data directly from here just like I was able to do previously. Remember, like if you recall from previous sessions, when we had a shapefile, we could simply drag it from the catalog to the map window and it would simply just be added to my contents pane and I could visualize the data. Here that didn't work. So I had to manually add data from here. I could click here, it'll take me to that folder where I've kept the data and then I can from there I can simply import this data. I can import the XLX file, that is the Excel format, or the CSV file, it doesn't matter. Okay, all right. So the quest that I have is I want to now, I will remove all the maps, and the quest is that I want to now visualize these data spatially. Okay, so for that we go to the data set, we right click, we say display XY data. We click on display XY data. So it gives me a new window. It says input table is groundwater level 1998. Perfect. Output feature class. It's asking me where to put a feature class. I'm going to give it a location. I'm going to say, okay, give it to me right here. So I want groundwater level 1998. So I'm saying Excel to shape or feature, right? .shp because that's the format I like. And then X field and Y field. So X is longitude and Y is latitude. Okay, you can imagine, latitudes are vertical lines on the Earth's sphere. So if the latitudes are changing, we are going along the y-axis, and longitudes, when they change, we are actually going along the x-axis. So y is latitude, z We do not have a Z field, right? Why? Because we don't have a height. Our data is 2D, it's not 3D, right? So with regards to location, spatial domain, our data is 2D. We have 2 coordinates, right? We don't have 3 coordinates. Okay. Very, very important coordinate system, it is WGS 1984. That is very critical because remember, all my vector files are WGS 1984. So if I'm to actually overlay them on a map and make sure that if I see a well location at a given sort of with some reference of a district, it's indeed in that district. I need the exact same projection system. So that's great. It has already provided me the projection system that I like. So I'm going to say, okay, there we go. Okay, so here on this screen, on your screen, what you see is a groundwater level data set for 1998 as a shape file, right? I can now, right click and open attribute table. The same attribute table as earlier opens, right? There are 1,309 units in this attribute table. That means there are 1,309 unique wells distributed across the Uttar Pradesh state, right? And not only the shape resembles UP, but if I actually now check UP state vector file, see what happens is that I'm actually able to find the envelope of these wells. Now this is phenomenal. I can go from a attribute table in ARC to an Excel file, and I can start from an Excel file and come to ARC and do all the manipulations I like. Okay, all right. So what else can I do? Okay, so one thing is I can probably look at the properties of these data. Well, let's look at the spatial reference. Well, WGS 1984, I specified the GCS, right? So it is the same as I like. The angular unit is in degrees, and so on and so forth, right? So there are all these details. Now I can also view which district has which data. Okay, so I can go and check the districts file. Here we go. We can see that some districts have much higher density of monitoring relative to some northern districts. Maybe these are hilly regions, remote areas. It's not possible to put wells or monitor them. It may be very costly, and hence you may have a lower density of wells in those regions, right? It could be a research question to ask why some districts are sampled more aggressively than others, right? I mean, you might want to figure out, that's a good place to start in terms of analyzing the data. Very interestingly, the western districts, which are all that are counted as NCR. So if I were to label these data, right, these districts of Ghaziabad, the district called Gautam Budh Nagar, that is Noida, these are part of the National Capital Territory, Baghpat. And often we come across, popular press about the depletion problem in these districts. And yet what we see is that they are not so densely, monitored. There are, let's say, 3 wells in Gautam Budh Nagar and 3 wells in Ghaziabad, right? But by contrast, Meerut has many more wells, Muzaffarnagar has many more wells, and so does Bijnor and Hapur and Bulandshahr and so on and so forth, and for that matter, Mathura, right? So these are some interesting things. They are starting points in a research, journey, right? Now I might want to figure out, okay, can I actually visualize the water levels across districts? Well, let's try. Let's remove the labels because we don't want to clutter. We go back to our, point data, and we say symbology. Okay. Now under symbology, I will say, okay, you know what? I want to look at proportional symbols. I want to look at proportional symbols, and I want to look at the field which is post-monsoon Kharif. Well, I don't see it here. Okay. So ArcGIS is not reading it. So for that, I will go and I will now open my attribute table. I will add a new field. I will call the field groundwater 1998 meters, or let's say MET, or just M, and I like to have these things. Okay, so I'm done with that. I would like to have the data type as double, and I will just say I'm done. So it'll say, do you want to save this change? I'll say yes, I want to save this change. Perfect. So I have my new field, groundwater 1998 meters. I'm going to right click. I'm going to say calculate field, not calculate geometry. Calculate field. Okay, I go there, I say groundwater 1998 meter, I want this to be equal to post monsoon, and I'll say apply. It'll give me, it'll do it, it has done calculations, right? So I can see the values are similar, but it has given me a lot of warnings. And if you pay attention, the warnings are where the post monsoon level was NA, and it doesn't know what NA is. NA is a text string, so it converts it to zeros. Okay, so this is a caveat, so you have to be very careful about this caveat, right? Okay, so apply. Okay. Okay, so we have a new stream now. Let's again go back to symbology. There it is, and catching the field groundwater 1998 meter. I'm going to use it. Wonderfully, it gives me a visual understanding of groundwater status in 1998 across districts. Well, it does it in 4 classes, or let's say 5 classes, which go from 1 meter till 10 meter and above, right? So these are just less than or equal to 1 meter, 1 to 2.5, 2.5 to 5, 5 to 7.5, greater than 5, 10. So a larger circle resembles a worsening groundwater depletion problem. Okay, so larger circles are a reflection of, greater problem. So I can play with the template. So, minimum size, I don't want the sizes to be so large. So I'm going to say minimum size is 1 and maximum I want the size to be 40. Okay. What that does is it makes my graph look much clearer, right? My visualization becomes clearer. So I'm done with symbology, but something I learn by this symbology is that I have some depletion problem in 1998 in the bordering districts of NCR, but not so much, maybe on the southern side. And the depletion problem was certainly higher in the southern UP belt, that is south of the Ganges River, than in the north. So I'd see no real depletion problem happening in the north, whereas south was already stressed so far as groundwater resource was concerned, and this is 1998, right? So I'm talking about 25 years ago, right? Okay. All right, so I have visualized, I've done some symbology, I've visualized this data. Now I may have a query that I want to learn about average groundwater level inside a particular district or across all districts. So what do? Well, I transport my knowledge from how I intersected the line feature with the polygon feature. I'm going to do the same. I'm going to go to geoprocessing. I'll say show me geoprocessing, go to analysis, overlay, and intersect. What are my input features? Well, my first input feature is UP districts. Okay. My second input features is the groundwater levels. Okay, I'm going to rank 1 and 2 just like I did previously. I'm going to give the address of my output feature class, and I'm going to say UP districts groundwater 1998 post monsoon, so PM intersect dot shape. Yes, I want to join all attributes. I want the output to be same as input, right? I actually want it to be a polygon. So let's see if it does it. It won't do it because it is only giving me 2 options here. What if I were to change ranks? I'm going to make it 2, make it 1. Let's see if it allows me to save these things as a polygon. It doesn't. So I'm just keep my ranks. My districts are my primary query. I want to understand the groundwater situation within a district. So I want to take an average, or I might want to know standard deviation of groundwater levels in a district. I might want to know the median level in a district. So I basically want to sort of do some kind of a spatial join between the district and the groundwater file. I know that wells are also identified by district, so I could directly do it in the Excel sheet. But I could also do it, if I did not have that identifier in the groundwater data, I could still use the lat long information and then join it to the districts. Okay, you could do it to taluks, right? So the original groundwater file does not identify which well falls in which taluk. Well, by intersecting the data, you could actually join the taluks to the groundwater wells, individual groundwater wells. Actually, you should do that as a homework, right? Okay, so I'm just going to say run. It's going to run it, and it has run it. Fantastic. So I'm going to open the attribute table, and it's going to now show me for Sonbhadra, right? I'm going to say select by attributes, select a field, I want name 2, and now I will look at, let me look at something like a Gautam Buddha Nagar. Okay, so I have these 3 wells in Gautam Buddha Nagar. Fantastic. I can see that they are now selected. So I'm going to now, only work with these, and I'm going to see where are they selected on my data. Okay, there you go, there you go. All right, all right, all right, all right. Gorakhpur, Amethi, Raebareli, Amethi, Unnao, Azamgarh, Balia, okay, Ghazipur, yes, okay, okay. For some reason, I'm not able to, okay, wait a second, let me see if I can, okay, so for some reason, I'm not able to find the selections in this. I'm just thinking whether they may be in another attribute table. Okay, cool. So whatever. But the thing is, I could just take an average of the levels at these 3 wells. I could calculate the standard deviation from these 3 wells. Of course, it's a small sample metric, but it is what it is, right? Okay. So now, just like earlier, I could export these data, this table, to Excel. So for that, you can actually fall back to what we did with the railroads data just 5 minutes ago, right? We could take these files and then merge them with some other files, auxiliary Excel files. We could do these things at state level. We could do these things at taluk levels. And if you have a village shape file, you could do them at village shape, levels. Okay, so you understand how we can sort of manipulate the data accordingly. Okay, so that's about it. We have seen vector data of 3 types. We've seen how to manipulate them, how to store those data, and how to visualize those data, use symbologies to create, informative maps, right? Publication ready maps, really. And finally, now is the time to look at some raster data, right? So another data type that we have worked with, and see if we can now sort of, find ways to not only visualize raster data, manipulate them, but also sort of read them into polygons like districts, or something around an outer ring of a well, right? I could just draw an outer ring of a well and read those data in the districts, and then export tables into Excel and do some manipulation, some analysis. Okay. All right. So thank you very much for your attention. That's about it for session 4. We'll do a short session on raster data shortly later. See you then. Thank you.